Hello and welcome back. In this video, we're going to be setting up a multi-node Kafka cluster, and we're going to be understanding some key concepts of Kafka like leader, follower, replica, ISR, controller, and etc. To properly understand all these things, we need a multi-node Kafka cluster setup. And that's what we're going to be setting up in this particular video. So if you have started learning Kafka right now, then you are in the right place, because 70 to 80% of this video has been recorded with latest Kafka version, which is 4.x. And we have created a multi-node Kafka cluster in KRaft Mode, where no Zookeeper has been used. And also, if you are still stuck with a legacy Kafka environment, maybe because of your office, and trying to learn all this concept, still you can follow this video, because in 30% of my video, I also used a little bit of Zookeeper by going back to 2 or 3 versions before when Zookeeper used to exist, just to make sure you guys can also relate everything and put it into practice. So if you are a fresher, experienced, or somebody who is preparing for a job change and appearing for a Kafka interview, for all of you guys, this can be a one-stop solution. Let's just get started. So far, we are working in a single node Kafka, right? But today, I think we have enough of understanding about topic, how a Kafka topic works. Now I think it's time to go for something called as leaders, followers, and replica, and ISR. Okay, there are a few terms: leaders, followers, replica or replication factor, ISR. Very important to make your core Kafka knowledge strong. Okay, so first of all, I'll be starting my Kafka server. So I will go to my terminal, Control++ to expand this a little bit. Kafka server stat .sh, and I'll be bringing in Kafka properties file. Where is that? Inside the config, right? So go to config, bring in the properties file of Kafka. Okay, I'll be starting the Kafka in KRaft mode. I will be bringing this server.properties file to here. Let's just start this. Oh, okay, I'm getting this problem: meta properties is not available. Basically, this folder right now does not exist in my computer hard disk, and obviously there is no meta.properties file available. So maybe I'll be formatting my Kafka folder one more time. I've copied this command, Kafka storage ss format. I'll give a unique ID, random UUID. I told you guys how to generate this one using the Kafka storage.ss.random UUID command. You can generate some UUID like this. Then provide your server.properties file to enter. It will be formatting everything, and I'll be starting my Kafka server. Okay, my Kafka started, right? Now the things that I'll be discussing today, let me just open up a new window. The thing that I'll be discussing today, see guys, whenever we are creating any topic, right? Let's say I want to create a Kafka topic. I'll copy some command from here. Kafka topic sh, connecting to this server, create command, and I'll be creating the topic. And let's say the topic I'll be creating is test. I'm starting this topic, right? So by default, how many partition has been created? 1 partition. You guys know about that, right? But let's say if I'm gonna create test topic with partition 3, okay, then okay, test topic already exists. Let's say test 2 topic I'm creating. Okay, now you know that I'm creating a topic with 2 partition. So you guys know this, that if I'm gonna go to my my folder where the Kafka is storing its log, if I'm gonna go to the folder, which is the temporary folder, KRaft combined logs, this folder, Kafka is storing the data. Here I have created the test topic, right? I have one folder like this, one directory, partitions are the directory. And then I have created another topic with 3 partition, test 2, right? So I have test 2, partition 0, partition 1, partition 2. So 1, 2, 3, we have created 3 partition, and these are just directories which has been stored inside our local folders. You guys know about it, right? Now the thing that I'll be doing today, I think the same question has been raised by, if I remember it well, by Sayed. This is not the exact purpose of the partition. The partition, we should be splitting inside multiple brokers, but right now we have only one broker set up, right? We have only one Kafka server running over here. But in real time, we should have multiple partitions splitted across multiple servers. Think like this is one broker, and like that, let me create a couple more broker. And like this, you're going to be having in real time. This is what we call a Kafka cluster, right? Like multiple number of brokers. Let's say if I'm creating a topic, right? If I'm creating a topic, let's say topic test with 3 partition, right? So this will be test topic partition 0, okay? And same test topic partition 1. So see, right now it is splitted. Previously it was like this. We have one server and we are creating partitions, right? We have one Kafka server and we have partition like 0, 1 and 2. Okay. Right now we'll be creating 2 more node and we'll be splitting the topic across the partitions like this, right? Sorry, splitting the partition across the server like this. Okay. So right now, all total, this is what we're going to be calling a Kafka cluster. I have told you guys, right? In real time, it's all about the cluster. At least you should have a couple of cluster or maybe 3 cluster as a good practice in your, like in a real time application. So for an example, I can treat all these guys as a group of node working together, something like this, like a cluster. Okay. So right now I do not have 3 different computers where I'll be creating a cluster, but I'll be starting 3 different Kafka node inside my local machine. Right now in my local machine, only one is running, right? The one that I've started over there. This one, right? Now like this, let's just start couple more Kafka broker, okay? As you have seen, like whenever I have started my server, it was complaining about the meta properties is not available. So maybe I'll be formatting like maybe a couple of time, creating couple of log folders where Kafka will be storing the details like the KRaft combined logs. Maybe 2 more folders I'll be needing like this. So every server will be keeping their data like this in order to maintain like whatever the data will be storing, whatever the topic will be creating. Current server which is running, we have one KRaft combined log folder where Kafka is maintaining its data. I need to do some work like to configure things so that my Kafka can create folders like this. This will be a tedious job. So I'm thinking not to do the things with KRaft like with the KRaft mode, rather I can go with the Zookeeper. Okay, that will be a little bit of easier process because my goal is to show you this thing, like how I can create topics in multiple broker and what do you mean by leader, what do you mean by follower, what do you mean by replication factor and those stuff. So I will turn off the Kafka which is running in my KRaft mode right now.
Hey, you might have an absolute question right now that, hey Vilas, why do you want to use Zookeeper here? Because what I know from the latest version of Kafka, Zookeeper is completely removed. And that's why I think you are using KRaft mode throughout this entire course. So why do you want to switch to the Zookeeper mode right now? Well, the answer is this is just to give you simple explanation. So previously, Kafka needs Zookeeper to run. So first we need to start Zookeeper, then we have to start Kafka, then only the thing works. But right now we can directly start Kafka just like a standalone server, and we do not need Zookeeper. That's what we say KRaft mode in Kafka, where no Zookeeper is required. If you want to talk about before 4.x version when we used to have Zookeeper, or after 4.x version where we don't have the Zookeeper, the core Kafka concepts remains the same. So here we will understand the core Kafka concepts like leader, follower, replica, ISR, which are the key terms of Kafka. And to understand these things, we need to have more than one broker, maybe 2 brokers or 3 brokers. And to set up all those brokers using Zookeeper is going to be a little easy. So I want to continue with Zookeeper for the next 30 minutes of this video. And once you understand everything, I will switch back to the KRaft mode again. And let me tell you, setting up a multi-node Kafka server using KRaft mode is going to be a little tedious and going to take you a little bit of time. So without wasting all our energy setting off a 3-node Kafka cluster, let's just understand the real business right now. And once we understand everything, then we can switch back to the KRaft mode. We'll set up everything by ourselves, and I'll tell you everything how to do that right after 30 minutes.
So I will turn off the Kafka, which is running in my KRaft mode right now. Okay. So maybe before that, I'll be just showing you one thing. The current topic that we have, which is test2, if I'll be describe this topic, okay, like this. Now I can see there are 3 partitions. If I'm going to be describing this topic, okay, there are 3 partitions. But see, there is some details like partition 0 we have, partition 1 we have, partition 2 we have. But we have something called leader, we have something called replicas, we have something called ISR, in sync replica. We'll be talking about what these guys are. But you can see I have partition 0, partition 1 and partition 2 available for the topic test 2. There are 3 partitions, and these topics are present inside the leader, which is 1. 1 means the broker ID. By default, the Kafka server, which is running right over here, having a broker ID of 1, if I'm not wrong. By default, see, broker ID is 1. So this leader 1 means inside the broker ID 1, the broker ID or that particular server only holding all the 3 partitions like this, right? And this is my broker, which is first broker. Okay, so now like that, I'll be creating right now multiple brokers like broker 2, broker 3, and I'll be dividing my partition into multiple brokers. Okay, so that even one broker will die, rest of the broker can do the things or do the job for me. I'll be coming back to this particular point. As I have shown you the KRaft combined folder, this is the broker 1, which is broker ID 1. This broker is already running and it is holding all the 3 partitions that you can see over here for test 2. Okay, 0, 1 and 2, and you can see 0, 1 and 2. Okay, so now let's just create a Kafka cluster. Okay, so first of all, let me just close this, and this KRaft mode Kafka, I'll be turning this off. Okay, I will just run this with Zookeeper because it will be a little bit of easy thing to do. Okay, I have told you guys you can run Kafka without Zookeeper, but you can also run Kafka with Zookeeper. So Zookeeper is going to maintain the data Zookeeper will basically help you to communicate between all these 3 servers, how they can be in sync, how all this broker that will be creating inside one cluster, the way they will be communicating, that can be taken care by Zookeeper. Okay, so I will be just going with the Zookeeper. I'll be starting Kafka with Zookeeper because this will be taking less configuration for me to do. Okay, so that's why I'm just going for it. You can also create 3 Kafka servers like this using the KRaft mode without using Zookeeper. But let's just start using Zookeeper a little bit today. Okay, let me go to my Kafka binary. Where is that? Go home, and this is my Kafka folder, and this is my bin. Can I start Kafka directly without Zookeeper if I'm not using KRaft mode? Anyone? If I'll be directly starting my Kafka without Zookeeper, can I do it? Something like...
No, it won't happen.
It won't happen, right? Where is Kafka? How to start Kafka? Kafka start, server start, right? This is the command I'll be using. So Control C, paste it, and then I'll be needing the properties file, right? If I'm using the KRaft mode, I'll be using the properties file inside the config. Inside the KRaft, I have the server.properties. But now I'll not be using KRaft mode. I'll be using the direct config file. I have the server.properties. I can drag it right over here, do a command ++, and I can just do enter. Kafka will start, but it will be keep on looking for Zookeeper. As Zookeeper is not running, it is throwing me exception. So let me terminate this one. Before starting Kafka, let me start Zookeeper first. So I will create another command window like this, and I will run Zookeeper first. Okay. So, okay. How to start Zookeeper? First, I need to get Zookeeper batch file. Sorry, the sh file. Where is that? Zookeeper server stat.sh. Copy this command. Okay, paste it over here, and then I'll be giving the properties file. Go to the config right here,
Inside the config, I'll be getting the Zookeeper properties, drag it to over here and do a start. So your Zookeeper has started. Okay. Now let's just try to start Kafka like this. Okay. So your Kafka is right now turned on. So we have started our first broker, which have the broker ID 0, and it is running in what port number? It is running in listener port. Look at that, where it is right here. Okay, it is running in port number 1992, the broker 0. Okay, so you can think like we have one broker right now, and this guy is running in port number 9092. Okay, so and the broker ID for this is 0. Okay, so the broker, so I think broker ID is broker ID for this is 1. Broker ID is 1. Okay. Okay. So now we need to start two more server right now, just the way that I have shown you like this. Okay. Let's just do that. Now let's just start this one. So I will start it in port number 1993 and broker ID I'll be using, let's say this one is my first broker. What is that? Let me just see. Broker ID for this is 0 or 1, or broker ID is 0, right? 0 means the first. Okay, I'm gonna say this is the broker ID 0. I'll have one more 1 and I'll have one more 2. Okay, 0, 1, 2, 3 brokers. This will run in 1992, this will run in 1993, this will run in 1994. Okay, so let's just start this one. So now I can open another terminal window and start Kafka. And to do that, I will go to my previous Kafka command that I ran here. Kafka server start sh config folder, and I'll be copy the server.properties file. Okay, and I'll paste it over here. Will it work? Let's just see. Let's just do command ++ to expand this. Kafka server start, and I'm giving the server.properties file from the config folder, which is available. Do a enter. Okay, now am I able to start it? No, it is not running. What is the issue? Because I think the port number is already running, and this particular, so basically when right now I have started Kafka using Zookeeper, right? So if you're gonna go to the temp folder again, let's say go to the temp folder. Okay, here if you're using Zookeeper, this is the temp folder. This is the log file it is creating, where it will be writing your log, right? Your meta properties is created over here. Okay, so right now when I'm starting Kafka again, it is trying to create the file inside the Kafka logs, which is already used by the server 1. So obviously it is logged, and obviously I think the address are also used. So 1992 port is already used. So now let's just do one thing. I will go to my Kafka directory. Where is that? Kafka directory right here. So inside the config folder, I will just edit the server.properties file, like where the server that I'll be creating, where it is going to maintain its log, okay, where it is going to store its data, in which port number it is going to run, what the broker ID for this particular server is going to be right now. Right now, I want to run it in port number 1993. Broker ID should be 1, right? Let's just do that, and let's just define that. So what I'll do, I'll create a folder here called delete. I'll be deleting it later. And I will copy the server.properties from here, go to the delete folder and paste it. So I will create two servers. I'll be needing two server.properties file. I will just rename them. Okay. This should be my server 1 properties. So server 0, this is the server 1, and the server 2. Rename, and this one will be server 2.properties, right? So because each server that I'll be running, I'll be doing the configuration inside this properties file, because using this properties file, I'll be starting my application, okay? Or I'll be starting my broker. So let's just open this with the text edit, the first server 1, okay? And right here, I will do some configuration modification. So the first broker ID is 0, which is already running. Let me make the second one as 1. So 1 means like it's starting from 0, 1 means 2. Okay, so broker ID is 1 for this server. So I will uncomment the listener port and I'll make it 1993 where it is going to run. Okay, and also I'll do one more thing. The temp folder, log.dir folder. Now this folder is already there. This is used by my first broker. So this one will be used by the 01. I'm going to say 01 means the second because the first one is starting from 0. So this is where this server is going to keep on writing its data. Okay. So I think using this file right now, I'll be able to start my my second broker. And like that, in the server 2, I'll just do some modification. Okay. I will close the other file. And this is for the server 3. The server 3 will be using this file, command ++. Okay. Broker ID will be 2. The first one will be 0. Second one will be 1. Third one will be 2. The listener will be 1994. Like this, and the log file I'll be using 02. I'll be appending over here. Okay, let's just do Control S. I think I'm all set. Close this file and let's just copy the Kafka command one more time. Kafka server start whatever server properties. 1 second. Okay, let me just start one more broker. This one I'm going to be starting off right now. I made all the configuration changes in the properties file. Let's just go to a new terminal window and I'll be opening this. All right. And I will just write Kafka server start and pass in the properties file. But for the second broker, my properties file that I have used is 01 or 1. Can I see that one? 1, server 1. Okay, this is for the second broker, server 1.properties, and this is there. This is not inside the KRaft folder. This is inside the which one? This is inside the delete folder, right? Inside config, I have a delete folder. Inside delete, I have copied this particular properties file, right? Let's just start it. Let's just see whether it is starting, and now it is up and running. I feel. Let's just verify the broker ID. The broker ID should be 1, which is good. And it is running in port number what? Yeah, it is running in port number 1993. Okay. Now let's just start one more server. Okay. So new window. All right. I'll be copy pasting the same command, Kafka server start command. And again, I'll be starting it using the server 2.properties, and it is inside the delete folder of mine, and inside that I have this server 2.properties. Let's just do enter. It is also started. Okay, let's just verify the port number and the broker ID. Broker ID should be 2. Can I see the broker ID somewhere? Broker ID 2, and it should be running in port number 1994. Okay, so I have 3 node running right now, just the way that I have shown you, like this. Okay, broker ID 0, 1, and 2. Okay, now let's just do one thing. I have all this Kafka node started. Now I will be creating a topic, okay, with 3 partition. And let's just see the topic partition is splitted across the broker or not. So what I'm going to be doing, let's say Kafka topic I'll be creating, right? Kafka topics .sh. Okay, then I'll be connecting to one server. Okay, so let's say I'm going to be connecting to Bootstrap server, the same one, localhost 1992 server. I'll be connecting. One node is running over there, and here I'll be creating a topic, right? And I'll be creating a topic. Topic name is what? Topic name is, let's say topic name will be test. Okay, this topic I'll create. Okay, before I create this topic, I will go once, go to a folder, the temp folder. I'll go once, temp folder. Now look at that. I have 3 folders created. This is maintained by this guy. Okay, and this is maintained by this guy.
okay, and this is maintained by this guy, okay. They will be storing their data. Right now, inside all this thing, we do not have any topic or anything, right? We have nothing inside these three things. Okay, now let me execute my topic command, okay, but I'll be create this test topic with 3 partitions. So partitions 3, okay. Let's just do a enter. Topic has been created. So I have a multi-node Kafka running. So I'm expecting this behavior. Now my test should have 3 partitions like 0, 1, 2 splitted across the broker. At least let's just see whether that happened or not. Because inside the, okay, can already see, right? If I'll go over here, test 0 is here. What I have given, dash dash test 0. Okay. Dash dash, the topic name should not have dash dash, but yeah, anyhow it is created. This is 0, this is 2, and the second one has the 1. So we have topics splitted like this right now, okay, inside our cluster. But yeah, before that, let me create one more topic and let me just say only test. Okay, topic created because I'll be using this one. So you can say test 0 has created over here, and test 1 has created over here, and test 2, maybe other one. This one has the test 2, then this one has the test 1, the other one has the test 0, right? It is right now splitted across the broker. Is this thing making a little bit of sense right now? What I am trying to achieve, what I have done, and from
Vilash,
yeah, Shivam.
I have a doubt. I mean, we created a broker on 1992, but logs are creating in all server. How it is
Exactly.
possible?
Because here one server is behaving as a controller, okay. Once you create like the controller is the main server, okay. Let's say the test, just for understanding I'm telling, let's say this one is working as a controller. Once you give a command, once the topic is created over here, it will communicate with the other server and create one partition right over here. I'll be talking about, like, just for now, you just think like all these 3 server working together as a cluster, okay. So they can communicate and pass data between each other, Shivam, okay. Just like your microservices, it is also a distributed system. These are not 3 individual computer or 3 individual Kafka node. They are a clustered node, and we are splitting our topics partition across them for balancing, for load balancing. So some data will go to here, some data will go to here inside this node, some data will go over here. In real time, this is one computer, this is one computer, this is one computer, but I don't have 3 computers right now. So I'm creating a cluster inside my local only, Shivam, okay. But I'll be coming back to this. This is going to keep on making sense as I'll be keep on explaining right now. But yeah, any other questions, guys? Like, it is making sense whatever I have done. Maybe you have questions. I think that will be clarified eventually. But this thing made sense, or like you are confused?
No, Milash, it's good. But I was just thinking like automatically, like brokers, partitions were assigned to different brokers automatically, right?
Exactly. Automatically it has been created. But how? Let's just try to do something. Now, topic I have created, right? Test topic. Let's just describe this. I will remove the create command and I will describe the topic. Now, are you seeing something right now? The leader thing, the previous example that I have given, and with this example that I have given, what you are able to understand by looking into the leader stuff. Just look at this one. So what you are understanding?
And number is different. Earlier, all leaders are 0 or 1.
Yeah, but previously everything was 0, right?
0, yeah.
Yeah, so right now it's 0, 1, 2. So what do you mean? What do you mean by that, Digna?
Different server, maybe it is.
Yeah, different server we have. These are basically the broker ID I have already told. So partition 2 is present inside the broker ID 0. Partition 1 is present inside the first broker. Partition 0 is present inside the broker number 2. So we have leaders, right? So what do you mean by leader right now? Okay, inside the cluster, the topic has been split into multiple partition. For an example, this is a leader. This is a leader,
and this is the leader. Okay, so what do you mean by leader? Leader means, imagine the broker which is owning that partition. That is what you mean by leader. Let's say inside the broker 0, test 0 partition has been created. Then this broker 0 is the leader of the test 0. That means whenever the producer is going to produce some messages, this is the server which is going to handle that particular data and will be pushing it to this partition. You might be thinking, okay, Vilas, this is only one partition, test 0 partition is only over here. So obviously the producer will be pushing the data to here only, right? So what rubbish you are talking about? I'm coming back to this thing. But for now you understand, whenever we are creating the topic, right? We have created the topic over here. During the topic creation time, the partition has been distributed among different broker. Let's say the test 1 has been created over here inside the 1993 broker ID 1. Then this is the leader. This is what we call the leader. Okay. Then what do you mean by followers and what do you mean by replica? We can also see there are something called replicas. Okay. And here I can see only one replica. There are some number 2, 1, 0. Like whatever the leader is there, the same number is there for replica. So in real time, like when you talk about replica, what do you mean by replica, guys? In general sense, anyone? Copy. Exactly.
Copy data. Duplicate.
Duplicate, right? So now let's just try to do one thing. Let's just see what is going to happen. Let's say I'm going to create a topic. Okay. I'm going to create a topic. The topic name is test2. Okay. I'm going to create it. So I'm going to give a create command like this. And I have created a topic. Okay. And what I'm going to say, this topic has two partitions 2, and let's say it has 2 replica. Okay. So replication factor is 2. Okay. So partition 2, there are 2 partition I'll be creating for topic test 2. That means partition 0 and partition 1. And there are 2 replication factor. That means for each partition, I need a copy. 2 is the replication factor. For an example, you are creating partition 0, right? For this partition 0, you create one partition where obviously that will be the leader. And also I need one copy for backup. Okay. So you're going to see like right now what is going to happen. See, if I do enter, it has created the topic with replication factor 2. Okay. That means right now if you're going to look at your folder, okay, I have the Kafka log folder, this one, 3 brokers are running. See, test 201. What is that? What is the one we have created? Test 2, test 02. This one we have created, right? Maybe I will just remove all the test thing over here. That will make more sense because otherwise you will be confused. It's a very easy thing. We should not be confused on this. Let me just delete all the previous topic. Okay. Now everything is empty, right? We don't have any topic present over here. Let's just come over here and let's just create a topic called, let's say, test one more time. Okay. Okay. The topic already exists. Okay. Because in the metadata is present. Maybe I'm gonna say new test or something. Okay. New test. Topic name is new test. 2 partition I want for this topic, and the replication factor I'm giving 2. That means for each partition I am needing 2 copies. Okay. Let's just see. So right now topic has been created. Let's just go to is broker right now. Here I have test 0, test 1. Okay. 2 partition. The first partition, the second partition. Let's just go to the other broker. I have new test 0. Okay. I have here new test 1. So test 1 is here and test 0 is here. And test 1, test 0 and test 1 is here. So total how many copy? For 0 I have 2 copy. For 1 also I have 2 copy, right? Let's just see how it goes. So what basically happened? Let's just see. Let's just describe the topic right now. I'm going to describe this topic that I have created. This topic that I have created, new test. Let's just describe this. Okay. Now let's just see what is going to happen. You can see some replicas are present and the leader. Okay, so what do you understand about this? So I have created a topic called new test. Okay, how many partitions are there? Whenever I have created it, 2 partition. Understand this, guys, very easy. So partition 0, who is the leader? Leader is broker ID 1. Okay, so I have 3 brokers, right? I have 3 brokers. So I'm gonna remove all this thing. Okay, I have 3 brokers right now. So I'm creating a topic. Topic name is new test. The partition 0 went to the broker ID 1. So topic name is new test. Topic name is new test, something like this. And this is the partition 0. It coming to the broker ID 1, and that is the leader. Okay, that is the leader. So when I created the topic, new test 0 has been created over here, and this is the leader. Okay, so I'm gonna put the star mark over here. Okay, next one, another partition I have created, partition 1 for new test, and leader is 0th broker. So I need 2 partition, right? This is the first partition, this is the second partition, and for the second partition is partition 1. So this is 0, this is 1, this is the second partition. It went to the broker ID 0. Okay, now good, we have 2 partition. Now we have given the replication factor as 2 when we created this, right? What do you mean by that? That means we need 2 copies for each partition. So one copy is already there. This is 1 copy, this is 1 copy. So already created. But 2 more copies we need. Okay, so right now what we need, see, now we have replicas. Replicas is what? Like how many copies of partition 0 is available. Now there is a copy of partition 0 available in broker ID 1, another is available in broker ID 0. That means it is creating another copy of partition 0 inside the broker ID 0. Initially, the first it is created one partition. First of all, the leader is 1. So when the topic created, 1 partition created over here. Then 1 replica is also available for 0 inside the 0th ID. That means over here. This is the replica of this guy. So I can just say this is 1 second. This is the replica. This is the copy of this partition. This is the replica, right? So this is the leader, this is the replica. Whatever data you're going to be pushing it to this partition, the data also will be stored over here as a copy. And also for the partition 1, it is available in the 0th broker, right? So partition 1 is available in 0th broker, which is good. That is the leader. When we created the topic, it has been created over here, the partition. Then its replica is available in second one. Okay, 1 copy is available in 0 where the leader exists. 1 copy is already available over here. We need 2 replication factor, right? So we need 2 copy of that particular partition. One is already available as a leader, another one available inside here, inside this broker. Okay, the second one. Okay, so now this is the second one. This is the replica. This is the replica of this. Let me just give an arrow as well, and let me just expand this and see this one also. Let me just give an arrow and let me just expand this. Look at this. This works like this one. Okay, so now you think, now I'll be just deleting it. Just see like how many copy of test 1 and 2. There are 2 copies. Replication factor is 2. And how many copies of 0? There are 2 copies. Replication factor is 2. Okay, now we can see in the server 0 we have test 1 and test 0. Let's just see. I will go to the temp folder one more time. Right here in the Kafka log 1, I should have 1 and 0. See, 1 and 0. In the broker 1, I have only the test 0. I have the test 0. And the broker 2, I have test 1. In the broker 2 is using this repository, I have test 1. Now these guys are called leader and these guys are follower. That means whenever you're going to be pushing data to this is also going to push it over here. Whenever you're going to be pushing data to here, so basically whenever you're going to be pushing data using the producer, right? The producer always going to push data to this partition. Let's say you are sending data to partition 0. That means the leader partition in whatever broker it is inside, that will be only receiving the data, okay? And eventually it is going to transfer it to the follower, and this is the follower, right? So the leader and follower will always be in sync. So what is the benefit? Now you think about it. Let's say this broker is down. This broker is down. Now think test 0 is present over here, test 1 is present over here. Now think this broker is down. Still you can still be able to push data because test 1 is available over here, test 0 is available over here. Let's say this broker is down. Still you'll be able to push data. Test 1 partition is available over here, test 0 partition is available over here. So this is increasing the high availability. Doesn't matter if one broker is down, still your work will go efficiently because we have splitted the partition. If this broker is down, then this two broker will be keep on working for you and keep on receiving the data. And whenever this will be up, so basically I'll be talking about that, how basically that leader distribution come into the play. But is this thing making a little bit of sense? What do you mean by leader and follower? Now look at this particular description. The topic name is test, partition 0 goes to the broker ID 1, and that's the broker ID 1, or the broker 1 is the leader. The replica is available inside the broker 1 itself, and also one more copy is available inside the 0th broker. And same for the partition 1, the leader is 0, the 0 itself is the replica, plus another follower is available inside the broker ID 2. Is this much thing making a little bit of sense to you guys right now? Can you confirm me once?
One doubt,
Yes,
Nabila.
Digna. Yes.
The replica should be less than the broker number, no? Number of brokers. Less than
Absolutely. Absolutely. If you're going to turn up your, let's say I'm going to create like this. Replica should be less than the number of broker. That's correct. Let's say I'm going to say, if I'm gonna do, I'm gonna be showing you a few scenarios anyhow along the way, but let's say I'm gonna say I'm gonna create a new topic called new test 2, okay, and I'm gonna say create a new topic, okay. I'm gonna say the partitions are, let's say 3 partitions I want, and the replication factor, okay, I want 10. Enter. Okay, replication factor 10 is larger than the available number of brokers. Okay, so it's not like let's say you are not creating the cluster like this, right? And you are not creating the cluster like this, just the way we have created. You have a single node cluster available and you want to store copy of some partition that is not available. If you have a single node cluster like this, single node broker like this, you cannot have replication factor more than 1 because you do not have any broker like this to have a copy of this guys, right? So here maximum you can have the replication factor is 2, but you cannot have replication factor is 3 because 3 means you need 3 copy of this particular partition, you need 3 copy of this particular partition, but you do not have number of brokers to store that much copy of partition. So if you're going to turn off all of your server, and if you have only one server up and trying the replication factor things, you're going to be getting the same error over here. Replication factor and the number you are specifying is larger than the available number of brokers. Okay. Yeah. Thank you, Digna, for this particular thing. Yeah. So this much is making sense to you guys a little bit, right? So can you confirm me once? Any other questions?
Is it possible, like the same broker will can have the leader partition also, and as well as the replica partition also within the same broker?
See, there is no point of storing the replica in the same server, Akhil. Like if we apply common sense to that, isn't it? Think like, okay, if I have already that server where I'm storing that particular partition, and then I'm storing the same replica inside the same server, isn't it, Akhil? That doesn't make sense,
right?
Isn't it? Because if that server goes down, then the replica cannot help us over there.
So here is an example that we already had a walkthrough. Here we're creating a topic called test with partition 3, and we haven't specified any replication factor. So by default, the replication factor will be 1. So whenever we're creating this topic test, there will be 3 partition available. And as you can see, we are describing here, so we can see the partition 0, 1, and 2 available for the test topic.
But look at the leader assigned to each of this partition. All these partitions are splitted across different brokers. Let's say the partition 0 goes to the broker number 2, and that's the leader. Partition 1 goes to the broker number 1, and the partition 2 of test goes to the 0. So here the leader means that all the data or all the traffic that will be incoming to all these partitions, this leader will be basically handling it. Let's say for partition 0, the leader is 2, then whenever somebody is trying to write any data to the test topic partition 0, then the broker 2 is only going to handle the traffic. But if you're going to see here, the replica is also 2 for the partition 0. If you're going to see the partition 1, the leader is 1, the replica is also 1. For partition 2, the leader is 0, the replica is also 0. So in this case, we can say the leader and replica are going to stay in the same server or in the same broker. Technically, if you're going to think, right? Let's say the partition 0, the leader is 2, that means there where the partition exists, and also replica also exists inside the same broker, which is 2. So technically the leader and replica are going to be inside the same server or broker. But here we haven't given any replication factor. So by default, the replication factor is 1. So wherever the partition is getting created, that's where my leader is. And as the replication factor is 1, we have only one copy or we have only one replica, and that's the leader. So in this scenario, we can say the leader and the replica are pointing to the same broker. But in reality, if you're going to have more replication factor defined, more than one, then you will never have this kind of situation where the leader and the replica are going to be stay inside the same server, because there is no point of having them inside the same server, because if the leader fails inside a server and if the replica is inside the same server only, then it doesn't make any sense, because the whole point of having replica is to have the high availability and to make our Kafka broker fault tolerant. Okay, let's just wrap up right here, because I need animation to explain whatever I'm saying. Otherwise, again, it will create confusion. So you guys practice this much. You can just go ahead and create some partitions. Let's say 5 partition like this. Some topic you will be creating like this, and make sure, let's say 5 partition and the replication factor is 3. Can somebody tell me how many directory I'll have in total if I'll be creating this topic? See, I'm creating this topic. So now for the new test 3, how many, for this topic, how many partition directory I'll be having in total? Anyone? For this topic, in total, how many directory I'll have? Look at the partition and look at the replication factor. It will be always multiply this. 5 partition, I need it in 3 copy for each partition, right? 5 into 3 is 15. So for new test 3, if you want to go to your folder, like your temp folder, go to the temp folder. Now for each new test 03, right? See, here I have 1, 2, 3, 4, 5 partition, right? Now here also I have 1, 2, 3, 4, 5. Okay, and here also I'll have 3. 1, 2, 3, 4, 5 for the new test 3. Okay, so always multiply this. Number of directory will be 5 into 3, 15. But over here, yeah, I have each server having 5 copies. Each server having 5 copies, because I need 5. I have 5 partition, so 5 partitions available over here as well, over here as well, right? And over here as well, right? 5 partition for the test 3. But the thing is, the leader will be different. Okay, it's not like you, but just by seeing this, you cannot say, okay, here this partition is the leader. You cannot say that. For that, you need to describe. So you just do like this, see the partition and see the leader that we have over here. Okay, this is the answer. But the thing is, like with animation, but with animation, I'll be showing you what is the good thing to have and what is the bad thing to have. How many brokers I need to create, as a standard and all these things. Okay, but yeah, you can see the leaders and followers, and you can see the replica, and keep on answering your questions. But yeah, I'll just create some animations next time to make this thing more clear. Okay, but I think you should be okay a little bit with these things so far. Like
I will
how
have one doubt.
Yes, Subnik.
So for a particular topic, we can have only one leader, right?
Yeah, for a topic, for a particular topic, for a particular partition, we should have only one leader.
Okay.
So obviously this topic has 5 partition, right?
Right.
Okay, in every partition there is a leader, right?
Right.
Yes.
Okay. That means that leader is partition wise. Okay.
Exactly. Leader is partition wise. For every partition, there will be one unique leader. One broker will have that leader inside. Okay. And rest of the things are replica. Okay.
Right. Yeah, got it.
Well, if you're going to see here, let's say for the partition 0, we have 3 replicas, right? So out of the 3 replicas, there is a leader, which is the broker 0 is the leader over here. Just like that, for the partition 1, there are also 3 replicas. But out of those 3 replicas that we have available in the broker 2, in the broker 0, in the broker 1, the leader is the broker 2. So you always can think, whenever we define the replication factor, for example, here we have defined the replication factor as 3. So we're going to be having 3 copies for each partitions. Let's say for partition 0, we have 3 copies available in broker number 0, broker number 1, and broker number 2. Now, out of these 3 copies, who will be the leader? Kafka will decide it. Now, out of this 3 partition, the one which is inside the broker 0 is right now chosen as a leader. And rest of the replicas like 1 and 2 are the followers. So we got some glimpse of leader and replicas. And I hope we got some kind of basic understanding. But if you have any doubts on that, hold on. I have a lot of animations to come right now. From now on, we're going to dig deeper, but through animations. We will understand how everything is happening in a Kafka ecosystem, how leader and followers are getting allocated, how the leader election is happening, what is in-sync replica or ISR, how to set up minimum in-sync replica, how a producer is connecting to a Kafka cluster, how a consumer is consuming from a Kafka cluster, what is a Kafka controller, and all that. And the important thing, whenever we're going to be doing hands-on on this, I will be using a 3-node Kafka cluster, but created in KRaft mode. No Zookeeper involved. So from now on, everything will be with latest Kafka version. So you have 2 options. If you are practicing with me, first of all, go to the end of the video, follow the step-by-step guide to set up a 3-node Kafka cluster using Kafka KRaft mode, then come back over here and continue with all this. And the option number 2, which will be a recommended option as well. You can keep learning all the concepts right now with me. Watch me creating different things with the Kafka cluster, and don't give a damn about how the Kafka cluster has been created, because in the end of the session, you will be only creating all these things. But you can focus on learning the concepts and how everything works internally. Once you are done, you set up everything by yourself and start doing the hands-on. So I hope you have decided what to do. So let's continue with one of the very important concept, which is Kafka Controller and the work of it. In a typical Kafka cluster, we have many brokers that basically participate to form this cluster, isn't it? And out of all these brokers, one should be elected as a controller. In a given time, only one controller that exists inside this Kafka cluster. This controller is basically a Kafka broker only. which is there to manage all these brokers or all these nodes which are formed inside this Kafka cluster. So the Kafka controller basically manages other node, and also it knows the state of the other nodes as well. Let's say this is the Kafka broker, which is elected as a controller in this Kafka cluster. How that election process goes on, that's a different story. We will talk about it. But imagine all these three brokers right now agrees that this is their leader or master, who is their controller, who will be managing different cluster related administrative work, like where the partition will be created, where the topic will be created, how the metadata is going to be formed. Everything this guy will decide in plain simple word. Right now, as I said, in a given point of time, there will be one controller. So you may have 100 brokers, but out of that, in a Kafka cluster, there should be only one controller. Now, this controller job is it manages the state of the other node, because in a Kafka cluster, you know that all these brokers communicate with each other to make sure all these brokers are in sync with each other. So if one goes down, the other brokers or the other available brokers can handle the traffic. For an example, here we know that the workload is being shared between all these brokers. And obviously, to create multiple brokers, the only intention is that we need to share the workload. If our server is not getting traffic, then it is useless to create multiple servers or multiple brokers. So basically, as I said, Kafka is a distributed system. Here, we are creating multiple brokers to manage the workload only. In our development environment, we can start with one broker. But whenever we are going into production, we see, okay, right now some traffic is coming, so we can have 3 more brokers. We can put them into production, and maybe all these 4 brokers right now is going to handle the traffic. But let's say in future, we have more and more traffic coming, we can keep on growing more and more broker over there to handle the traffic and to manage the workload. But here is the question. If one of the active broker, let's say this goes down, then what will happen? Now, this is the work of the controller to remove that broker from the cluster and to make sure it is maintaining a good health inside the Kafka cluster. So right now, these 3 brokers will handle the traffic, and it removed the other controller that was present in the node. So here is another important question. Imagine here, this is also a broker, which is the controller right now, which is managing all these brokers. Now imagine this controller only goes down. Now what will happen? So as I said, in a Kafka cluster, in a given point of time, only one broker can be a controller. In this case, maybe again the election will go on between all these 3 brokers. And let's say right now the broker 2 has been elected as the controller. Right now, this is the controller will be managing this particular Kafka cluster. Even though the broker 1 will come back, maybe after some time, if that comes back, that will act as a follower, and this will still be the leader. Okay. So once the broker, which is the controller, if this goes down, then again the new election will go on. Another broker will be the controller and will manage the entire cluster. If the broker, which used to be the controller previously, if that comes back, then that will act as a follower only. Now let's just form a Kafka cluster by running 3 Kafka brokers. Well, I have already told you how to create a Kafka broker. So I'm going to directly copy paste the command right now. So I have told you that we will run all this command. We'll find all this cluster ID and 3 UUID that will assign to each of our broker. And then we need to format and create the log folder for each of the server. Let's say for the first broker, we will use server1.properties file to format it. For the server 2, then again, we will use the Kafka storage format command, and we will also create a new folder, a new log folder for server2.properties and another one for server3.properties. So let me just try formatting my Kafka log folders right now. So I'm going to copy this, paste it to enter. It is going to format my log folder. Right now, let's just go and check whether my log folder has been created. So inside my temp right now, this log folder has been created. And then I will run the same command one more time, just changing the properties file as server2.properties. And I'll go over here, paste it again, do enter. There you go. I think the KRaft folder, KRaft combined log folder for this logs02 folder has been created. And another one, I'll be doing the same thing for the server3. And I'm going to do this. So right now, another log folder will be created where the server3 will keep its data. So right now, let's just start all three of our Kafka server using the server1.properties file, and then another one using the server2.properties file, and another one using the server3.properties file. Right now, all my Kafka brokers are started. So right now, first of all, let's just confirm that we have a Kafka cluster present. So I will go over here, I'll clear my log, and I will write a command. So to check my cluster information and who is the controller, who is the followers, to check that information, I will run a command. So I'll go to my Kafka library right now. So I'm inside my Kafka folder. Let's just go into bin and let's just look for kafka-metadata-quorum. This is the one. I'll copy this. I'll go to my command line or terminal and I'll be using this command. And here I will just connect to one of the server and just try to find the metadata of that particular server quorum. So I'm going to do bootstrap server and I'm going to connect to any one of the server. So because they are part of the same cluster, let's say the one that I want to connect to localhost 1992, and I'm going to say describe and I'm going to find the status of it. All right. And there we go. So you can see the leader is the broker 1 right now. Okay, so maybe the same server we are trying to query for. There's the server which is the leader. There's the ID. The epoch, this is something related to the election of the leader, the way it is getting done. We will talk about this later. But you just see the leader ID is 1. And these are the current voters which are available. Now, this is ID 1. And this is the controller endpoint, 1993. I think this is the leader. And then you have the ID 2, then you have the controller endpoint over here, and you have the ID 3, and you have the controller endpoint over here. So these are the 3 voters that we have. And this is the leader, which is the broker 1 right now, which is the ID 1. That means 1993 controller is the leader right now. What if one of the leader goes down right now? So let's just say if a broker 1 is going to go down, if I'm going to do Control C here to terminate this, then still we have 2 more brokers over here and 1 should behave as a leader and that will be automatically happen. So let's just try to do a query one more time, the same thing. Okay. And obviously right now, can I do Control C because I'm connecting to the localhost 1992 right now. And I think that broker is not there, it's not available. So it is trying to connect to that broker and check whether that is available, and it is saying connection not established. Okay, I'm going to do one thing. I'm going to connect to another broker right now. Maybe I'm going to connect to, let's say, localhost 1990. I think I have one broker at 1992, one at 1994, and one at 1996. Let's just check with the broker who is at 1996, and let's just describe the status. Okay, now you can see the leader ID has been changed. Previously it was 1. Now the leader ID is 2. And these are the current voters that we have. One is ID 1, one is ID 2, one is ID 3. But there is the first broker is right now down. That's why we have a new leader which has been chosen over here. Now let's just say if this broker comes back right now, I'm going to run it again. I'm going to do Kafka server start and start this broker one more time. So if I'm going to start this again, let it up again. As I said, right now, this is going to be joining the cluster, but not as a leader or not as a controller right now. The controller broker is right now is 2 and that is up and running. So if I'm going to run the same command again, So you can see right now there is a no follower lag. Previously we used to have a follower lag over here. Okay, right now there is no follower lag. Maybe we'll talk about this later. Right now that broker is up, but still you can see the leader ID does not change. We still have the leader as 2. And if I'm going to run the same command again, the leader ID is 2. The second broker is the leader of that particular cluster right now. And these are the different porters which are available. All right now let's just try to analyze these 3 runs that we made. Let me go up from where we have started. We started connecting to the localhost 9092 server, and we are trying to check the status of that particular server, which is available inside this quorum. Okay, Kafka metadata quorum. And now what we can see, this is our cluster ID that we're trying to inspect. So this broker is part of this cluster ID. Okay. And here the leader ID is 1. Then the first broker over here is the leader. That means this broker is the leader. That means whatever controller that we have over here, that is going to be the leader controller. But there is another thing that you can see over here, leader epoch. That means the leader election has only been happened for one time. Whenever there will be a leader election will happen, this leader epoch will be increased. Okay, it will be incremented by 1. Okay, so maybe you can see whenever I turn my first broker, you can see here I was trying to connect to that particular broker that was not available. And then in my second run, when I'm connecting to another server to check who is the leader of that particular cluster, you can see the leader ID is 2. Here another time the election happened because the leader 1 I have terminated. That's why the leader epoch has been increased to 2. There has been an increment. That means the leader election has happened one more time. Okay. So right now you can see it has been increased to 2, but at that time you can see max follower lag time. That means we are not able to connect to one of the follower, okay, because it was kind of trying to sync up and there was some lag over here. There was some follower lag. The follower is trying to catch up with the cluster and there was some lag over here. And you can see in the third time when I ran, the max follower lag is right now 0. The leader epoch, whenever there is an election happens, you can see this value is getting incremented. And right now, if you want to try it again, let's say if I will right now basically going to terminate the server 2 here, okay. If I have terminated this one, if I'll go back to my terminal again, and if I'm going to query for this broker one more time, you can see again, there is a max follower lag over here. And right now the leader is the ID 1. Okay. And there is an election happens again. So the leader epoch is right now 3. Okay, so every time a leader goes down, there is a new election is happening that who will be the leader. Right now, the leader with the ID 1, that means the broker 1 is again becomes the leader. Okay, imagine a scenario. We have a 3-node Kafka cluster where we have 3 brokers available. And here I'm running a Kafka command to connect to one of the broker, which is 9092. It can be any of my broker because they said all these brokers are in sync. So that doesn't matter. Let's say I'm going to connect to one of the brokers so it can communicate with other 2 brokers as well and can distribute the thing. Let's say I'm connecting to the localhost 9092. Imagine the broker 1 is localhost 9092 and I'm creating a topic called test. I have 4 partitions and by default the replication factor is 1. So the replication factor is by default 1 only, but I have written it just to make sure there will be only 1 copy of each partition will be available. Now look at this. This is the topic test that I'm trying to create. All right. It has 4 partitions: test 0, test 1, test 2, and test 3. Okay, and replication factor is 1. That means like we have only one copy of each partition available, one folder of each partition available. So by default, the replication factor is 1, so nothing fancy over here. So my question is, so here, how these partitions are going to be assigned to each of the broker? So just understand this. Whenever we distribute the partition to each of the broker, Kafka actually follows a round robin method. It first sends the first partition, let's say, to the broker 1. The second partition goes to the broker 2 or broker 3, whatever it is. I have written broker 3 over here, so you can swap it. And then the second partition here goes to the next broker. Then the third partition again goes to the broker, another broker. So it's basically distribute everything in a round robin manner. Now the broker 1 got 2 partition, and as only one copy of each partitions are available, then all these partitions are leader by themselves, right? So the broker 1 got 2 partition, test 0 and test 3, and both are the leader. Broker 3 has 1 partition, and this is the leader. And broker 2 has 1 partition, and that's the leader. All right, but in this case, you might ask me that, okay, I don't see the role of the controller here. Well, there we come. Imagine all these 3 brokers are part of a cluster, okay? And as I said, in a particular time, one of the brokers should be the controller. In this case, imagine the broker 1 becomes the controller. And now the job of the controller is, whenever we give this line, imagine this is the topic creation line that we need to create a topic of test with the replication factor 1. Now the controller basically invokes this line, then creates the topic across the broker. So now you see this controller of broker 1 has the responsibility of the creation of the topic and distributing the partition of the topic across the brokers available inside the cluster. Now the next thing, what if I want to have a producer that needs to send data to the topic test partition 0? Now how that will happen? Let's just check this out. Right now imagine we have a producer that needs to send data to topic test partition 0. Okay, so right now this producer needs to send data to test topic partition 0. So here we go. Broker 1 has the test topic partition 0. And obviously this is the leader, this is the leader, this is the leader. This partition is the leader available inside the broker 3. This partition is the leader available inside the broker 2. This partition is the leader available inside the broker 1. Okay, now we do not have any replica for this partition, so we have only one folder available for each partition, and that folder is the leader only. Now here is the question that we have. I need to send the data to the test topic partition 0. Now how can this producer know where the partition 0 is available? Because the producer need to send data only to the leader partitions. In this case, only we have one replica available, but in real time, maybe test 0 might be available over here, test 0 might be available here as well. Now the producer need to send data to the test topic partition 0. Now the partition 0, this partition of the test topic is available inside the broker 1. Now how the producer will know that where the partition 0 is available among these brokers? I might have 10 brokers or 15 brokers, right? Now the producer will connect to which broker in order to send the data. How come the producer will know about it? Now this producer can actually connect to any of the broker that is available inside the cluster. Okay, let's say right now the producer we are creating by connecting to the Bootstrap server localhost 9096. Imagine the broker 3 has the port number 9096. Now this producer connect to one of the server or one of the broker which is available inside the cluster. Okay, and remember that all these 3 brokers are part of one cluster. Once we connect to one of the broker from the cluster, the broker will reply with the metadata information, the cluster metadata information. whatever the brokers available inside that cluster and the details among them. So this reply from this broker to the producer will contain the cluster metadata. For an example, we'll have different type of information over here. Now, the broker will let the producer know about the list of the topics available. In this case, we have the test topic available, right? And now the producer also will be told by the broker about the partition per topic is available. Now we have, for the test topic, we have 4 partitions available. And also with this reply, one more thing will come. Let's say the leader broker for each partitions. Let's say for the partition 0, broker 1 is the leader. For partition 1, the broker 2 is the leader. For test topic partition 2, broker 3 is the leader. So all this leader information, wherever that particular partition is available, all this information came with the cluster metadata. Now the producer basically knows where to send the data. Now producer need to send the data to the test topic partition 0. Okay. Now straight away the producer will look for the leader partition. And the leader partition for test 0 is available in the broker 1. So the producer will connect to the broker 1 and will push the data to the leader partition of the test 0. Well, we might have replica for test 0 as well. We might have replica over here for test 0. We might have replica over here for test 0. But the data will always going to be sent by the producer to the leader partition. Now test 0 being the leader partition available inside the broker 1, so the broker 1 will handle the traffic from the producer. Now imagine we are increasing the replication factor to 2. Now we have a topic called test which has 4 partition, but we have the replication factor is 2. That means for each partition, there will be 2 copies will be available. That means here, the total number of directory will be 4 into 2, which will be 8. So 8 directory will be there, where 4 will be leader and 4 will be follower. Let's just see that in action. So imagine here we have 3 brokers. This is my test topic. We have 4 partition. Imagine these are all the leaders. Okay. And then we have another 4 partitions, and these are the copy of all these partitions that we have. So as we have the replication factor here is 2, that means for each partition, there will be 2 copies will be available. For this partition, there are 2 copies. For this partition, there will be 2 copies. For this partition, there are 2 copies. And for this partition, there are 2 copies. Let's say among all these partitions, these are the followers. Imagine this yellow color ones are the followers and these are the leaders, right? So right now, the leader will be distributed at first in a round robin manner, something like this, across the broker, something like this, okay? And then the followers are distributed. And as we said, the followers are there to give us the fault tolerant, okay? So here, again, the distribution will happen. So we need to distribute, again, the followers. So should this follower goes to this broker? No, it should not go over here because see here already test 0 exists, okay, which is the leader. Imagine all this color are the leader partitions. Now the test 0, which is the leader partition, is already available. So we should not keep the follower over here. So whenever you want to distribute all your followers, first you need to skip one broker, okay, then you need to put the followers. So instead of putting it over here, you just skip the first broker, put it like this. Then this goes over here. Now this goes over here. Okay. And now this goes over here. Now look at this, how the followers has been splitted. See, test 0 is over here, but the copy of test 0 remains inside a different broker. See, test 1 is over here, but the copy of test 1 remains inside the another broker. Let's say the test 3 is here, but the copy of test 3 remains over here. And the copy of test 2 remains inside another broker. So whenever we are distributing the followers, we are skipping the first broker and then distributing it. Right? You understand it? Let's say I'm going to undo everything. Okay. This is how our leaders and followers are there. Now imagine my replication factor is 3. That means there is another set of followers are available. This is first set of followers. This is another set of followers. The replication factor is 3 right now. That means for each partition, there should be 3 copy. For test 2, there should be 3 copy. For test 3, there should be 3 copy. First of all, the leader will be distributed. The leader goes over here, then the leader goes over here, and then the leader goes over here, then the leader goes over here as a round robin way. Okay, and then the followers will be distributed. So here we started with this one whenever we started distributing all our leaders. So just skip the first broker, then go for it. So test 0 goes over here, then test 1 goes over here, then test 2 goes over here, and then the test 3 goes over here. Okay, now look at this. This is how everything has been distributed. Now, if you want to distribute this 4 again, okay, so how you will be distributing it? Let's have a look into this. Let's just get some space over here. So for the first distribution, we started over here for the leader. Then in the second distribution, we started over here. Then this is the third distribution. Maybe I'm going to give it another color. Imagine these are also the followers. Okay, now we need to skip the second one, start with the third one, something like this. Then it goes over here, then it goes over here, and then it goes over here. Okay, so this is how everything will be distributed. You just need to skip one broker and then go round robin again, right? So in this case, you can see the test 0 copy is over here. The test 0 copy is over here. The test 0 copy is over here, right? So now we are splitting our test 0 copies across the broker. Let's say if this broker goes down, we still have the partitions available inside each of my 2 brokers, right? And they can right now can handle the traffic. Okay, you got it? So that's how it works. Right now, let's just talk about a little bit about the replication factor. And let's just see how everything works as a whole. All right. So here I'm creating a test topic, partition 3 with 2 replication factor. So there you go. That's my broker. Out of all 3 brokers, one will be the controller. And this controller right now going to execute this command and gonna create the leader partition across all the brokers like this. Now, these are all the leader partitions that we have. And then as the replication factor is 2 here, the controller right now going to create the followers and it's going to split it across the broker. So we have 3 leader partitions and we have 3 copy of each partitions exists inside each of my broker for fault tolerance purpose. Right now, let's just say we have a producer which is going to push data to this. So we have a producer. Now imagine it needs to send data to test topic partition 1. Well, we have a partition 1 here. We have partition 1 here. So where should the producer need to send the data? Obviously, the guy who is the leader. Now the broker 2 is actually holding the leader of test 1 partition. So the data need to go over here. So whenever the producer starts sending data, it need to ends up over here. But how come the producer knows about the URL of this broker 2 where actually the leader exists? As I said, the producer can connect to any of the server. In this case, is connecting to the broker 3, let's say. The 1996 port number belongs to the broker 3. Let's say it connects to this and asks for the metadata. Now the broker 3 going to give all the metadata regarding all the partition exist, all the topic exist, all the leader for each partitions, everything right now this producer knows. It also knows how to connect to the leader partition for test topic partition 1. It knows the URL. So right now the producer basically used the metadata information and using that it knows that this is the broker which has the leader of test partition 1. So there you go. It needs to send data. It will send data to test 1 partitions and the data goes over here. And right now the work of the follower starts. Now for test 1, we also have a follower exist inside the broker 3, which is the follower replica. Now, the work of the follower replica is always is going to try to be in sync with this particular partition. So whatever data that we are committing over here, this guy always wants to be in sync with this particular partition or the leader partition. So this replica, which is a follower replica of test 1, exists inside this broker 3 has only one work. It always needs to connect to the leader partition in whichever broker it exists, and is always going to try to fetch the data. So it is going to read the data and going to commit the data inside this. Let's say the producer again going to send data to the partition 1. Where is the leader partition? In the broker 2. So test 1 partition, it wants to send data. It is inside the broker 2. There goes the data. It's got committed in the broker 2 in the leader partition. And then the follower partition right now again is trying to catch up. It's again going to read data and commit data. So this guy is always going to try to be in sync and copy the data from this leader partition. Why? Because if anytime this broker goes down, which has the leader partition for test 1, if it goes down anytime, then this replica want to be the leader. Right now, this is the follower replica. So if this goes down, it is trying to be in sync. So if something happens to this is going to be the leader replica, right? And that's its only motto. So the test 1 replica has only one job, that is staying in sync with the leader partition, which is test 1 over here exists inside a different broker. Now let me tell you this with a broader example. Imagine right now we have a replication factor of 3 per our test topic. So now our test topic has 3 partitions. Let's say the controller basically takes care of it and distributed all these 3 partitions across the brokers. And then there are 3 replica. So 2 more copies of each partition need to be created. Let's say here goes the test 0 partition, test 1 partition, test 2 partition. And these are the replica of these partitions. And right now the replication factor, let's say it is 3. So another copy of test 0, test 1 and test 2 has been created over here inside the broker. Now imagine if you are pushing data to test 1. For an example, let's say the producer is pushing data to test 1 because this is the leader. Right now, here we got a replica of test 1. Here we got a replica of test 1. As I said, right now this replica and this replica does have only one job, that is staying in sync with this broker. So these 2 replicas are going to keep on asking data from the leader partition and will commit the data into themselves. So both these things are trying to be in sync. So if this goes down, this will try to be the leader, and in the same time, this also want to be the leader. Obviously, everybody wants to be the leader, right? Let's say in some reason the broker 2 goes down. Now, who will be the leader? Either this replica or this replica? Well, that depends. Which of these 2 replicas are most up to date? If this replica is most up to date, then this will be the leader. If this replica is most up to date, this will be the leader. The controller will basically decide which of this replica is most up to date, right? Let's say in the selection process, the test 1 won. So right now the test 1 will become the new leader. And let's say here in the broker 3, we have the test 1 as a follower again. So the test 1 will continuously try to be in sync and always try to catch up with test 1.
Let's say here I am on my terminal and I am inside a multi-node Kafka cluster, and I will be creating a topic here. All right, here I'm creating a topic called demo. I'm connecting to Bootstrap server 1992. It could be any available Bootstrap server. I just need to connect to one. And here I'm creating a topic called demo with 3 partitions and the replication factor of 3. All right, let me just do enter. And you can see I have created a topic called demo. Let's just try to describe the topic right now. Now, this is the command to describe the topic demo. Do an enter. And here is the detail. You can see right now the demo topic, there are 3 partitions, right? And for each partition, this is the leader broker, okay? For partition 1, the leader is present inside the broker 2.
And you can see the other available replica as the replication factor here was defined as 3. We have 3 copies available for each partition. Let's say for partition 1, the leader is available inside the broker 2, and the replicas, all the 3 replicas are available inside the broker 2, where basically the leader partition exists, then the broker 3 and the broker 1. And the broker 3 and 1 where the folder partition exists for the partition 1. And the ISR. As I said, this is what we call in-sync replica. The replicas which are most caught up with this leader broker. Now let's say for the partition 1, the leader partition present inside the broker 2, but with the broker 2, the broker 3 partition and the broker 1 partition, let's say the partition 1 also exists inside the broker 3 and broker 1. And you can see inside the in-sync replica, these 2 brokers are also available. That means the followers which are available inside the broker 3 and broker 1 are also all caught up, and they are ready to be the leader in case anything happens to the leader partition, which is the partition 1, which is present inside the broker 2. Now let's just test if the partition 1, the leader is available inside the broker 2. Let's just do one thing. I will go back to my terminal where all of my 3 brokers are running. This is for the server 3.properties, server 1.properties, and this is the server 2.property. This is basically my broker 2. Let's say if I'm gonna do Control C and terminate this broker. Well, this one is right now turned off. Okay, I hit Control C. Right now this is gone. Now let's just go back to my terminal again. And right now, let's just rerun the same command. Okay, I'm right now connecting to localhost 1992 again. The broker 1 maybe, this is the one, and trying to describe the topic demo. Same command one more time. Let's just observe the partition 1. Now the partition 1, you can see, now the leader changed. Right now the leader partition is available inside the broker 3. Okay, so this is what you can see. Right now previously you can see for the partition 1, the leader used to be 2. Now the leader partition for partition 1 is broker 3. Okay, and replicas are available over here. But right now, in-sync replica is down to 2 things. It's basically down to 2 brokers because one of the broker is down. Previously, you can see for partition 1 here, the ISR was 2, 3, 1. These are the 3 node numbers that we have over here. But right now, for the same, the leader has been changed. But right now, if anything happens to the leader 3, the in-sync replicas are the leader itself and one more, the broker 1. Okay, but the other broker is down. That's why it's not in the list, because if the producer in the same time is pushing some data to the partition 1, then the down broker, right now the broker 2 is down, that is not actually caught up with the leader partition data, right? That means the partition 1 data right now does not have inside the other broker, which is down, which is the broker 2. That's why that broker is not caught up with all the data. That's why it's not inside the in-sync replica list. Let's just do one thing. Let's just go back and let's just start this server again. Okay, so let's just start this and let's just give some time to communicate all these brokers so that they can be sync up. And now if I'll go back to my terminal window again, let's just run the same command. And you can see for the partition 1, right now the leader remains the same, but the replicas and ISR, right now you can see the ISR is changed right now, right? Previously it was 3 and 1 for the partition 1. Now we can see the ISR is 3 and 1 and 2 because 2 node is up. And I think once it is up, it's communicated with the other brokers and copied the data from the leader partition, right? And that's why it is again inside the in-sync replica list. So what you are seeing over here, the in-sync replica list is changing dynamically. Previously, the in-sync replica was this for the partition 1, okay, 2, 3, 1. And for again, when I run this, you can see the in-sync replica list again changed.
And when I run this, the in-sync replica list is again changed. Okay, 312, here it was 31, here it was 231 for this partition 1. That means the in-sync replica list keeps on changing. This is the dynamic, is some kind of dynamic list you can think. Whenever some replica is not able to catch up and is down, then the Kafka is removing that particular broker, that particular node from the ISR list. So this is what I'm trying to prove. Imagine I have 3 brokers and these are the leader of my test partitions. Now there is a replication factor of 3. So the directories goes like this for the followers, splitted across the brokers. Now let's say we are committing some data to test1 partition. It ends up over here. The test1 of both replicas are trying to catch up and they are trying to be in sync. Now the leader for test1 partition exists inside the broker 2. So the broker 2 is going to maintain a ISR list and going to be updating the same thing. Now wherever a leader replica is there, that's inside the broker 2, that's where we are committing the data at first. So this is the first thing that we have in the ISR list. The next thing, now there are 2 followers. This partition, which is a follower replica, is trying to sync up. Now this broker 3 is a server, and this server may be there in a different country. Imagine this server is there in India if this is there in US. Whenever the broker 3, which has the partition test1, which is a follower partition, whenever it's trying to sync up with the broker 2, where the test1 leader partition exists, this call, which is a network call. So the network call might lag a little. So the broker 2 understand that the time the test1 will take to consume the data and to commit to it, it might going to take a while. So there will be a standard time defined by the broker. Let's say broker 2 will say, I will consider somebody is sync with the test1 partition if he will consume the data in 10 milliseconds, for an example. Right now, this broker 3, imagine is making a network call, consuming the data and committing the data over here within 10 milliseconds. Now the broker 2 will say, okay, perfect. I know there is a lag of 10 milliseconds, but at least within 10 milliseconds, you copied the data from here to here and committed it. So I'll update my ISR list, something like 3. Okay, I've written 1 here, that's fine. But I can say something like 3 over here. Just like that, if the broker 1 over here, which consists the test1 replica, which is a follower replica, which can fetch the data from the broker 2 within 10 milliseconds, then the test1 can be considered as an in-sync replica and will be part of this ISR. Have a look at this again. Data committed. They're trying to sync up. Broker 2 maintains the ISR for test1. And there goes the ISR values, which are the node which are synced up. Now consider a scenario. Let's say the data again committed to test1. Now test1 follower replica from broker 3 is trying to sync up and all caught up. But the test1 replica, which is the follower replica exists from the broker 1, let's say is trying to connect, but let's say this broker and this broker cannot connect. They are taking a while. It's taking a bit of time to catch up. If it is going to take a while, then it is removing the broker 1 information from the ISR list. It is just saying that the broker 2 right now and the broker 3 right now are all caught off. But here there is a slower connection, or maybe the broker is down, or maybe the partition here is corrupted. Something happened so that the data has not been written over here and is taking a while. But let's say after a while, the data is being committed to test1 again in the broker 1. And the broker 2 understand that right now everything is caught up. So the communication happens between these 2 brokers, and this broker 2 understand that, then again it is going to update the ISR list. So the ISR list is going to be a in-sync replica list, which will be keep on changing based on the replicas which are up to date or not. And that will be maintained by the broker 2, which is going to be the leader broker, where the leader partition available for test1.
All right, so here there is a very important consideration how basically the leader maintains the ISR list, what parameters takes into the consideration. Let's just talk about it right now. So imagine the broker 2 manages a ISR list and the values to be updated over here. So how these values are getting updated? First of all, whenever any data getting committed by producer, it comes to the leader partition. So the data goes over here, and imagine over the time, the data will be keep on pushed into this, topic, and the topics are backed by offset. So whenever any data arrives over here, that goes to all these offsets. Imagine sometime A is coming by the producer, then the producer is sending F, producer is sending D, producer is sending K, producer is sending L. So all this data is being committed to our topic, and this is how it is being stored with the offset behind the scene. Now the test one need to copy all the data from this leader. Now, if the data is getting copied over here with respect to some parameters and with respect to some standards, the broker 2 will consider the test 1 is in sync with the test 1 leader partition. Okay, so how do we define that? The test 1 follower partition from broker 3 is right now asking the data to broker 2. Let's say, hey, give me the data and I want to be sync with you. So let's say whenever it is asking the data, maybe it's asking the data from the first offset. Let's say 0, 1, 2, 3. Let's say it is asking for 4 elements starting from offset 0. Now the broker 2 gives the data to test 1, it consumes it, and then write it to the topic of test 1. This is the topic again, so it will store the data like this, and these are all the offsets. Now, once it commits all this, then again, this test 1 partition, which is a follower partition from broker 3, need to make a call to this leader partition. Obviously, this is a network call. There will be a lag. So we do understand that it cannot be exactly same with the leader topic all the time. So we expect a lag, but how much lag is okay? Okay, now let's say the test 1 is again asking for data. Let's say it basically consumed and committed the first 4 data. Let's say till the offset 3. Now it's asking for more data, another 4 elements from the offset 4. Now let's say this test 1 follower replica is again asking for data, and this broker 2 giving the data from the offset 4, maybe the another 4 elements, and it writes over here, something like this. Now the test 1 leader partition from broker 2 exactly know how much data has been consumed by this follower replica from broker 3. The way it tracks, because it basically knows till how much offset this replica follower has consumed the data. Now it knows that it has consumed the data till 7th offset. Okay, and it need to catch up 4 more elements, which is U, P, and M, that it need to catch up. Now, the broker 2 expects the broker 3 to have a lag, because the broker 2 knows that this is the leader partition. It knows that, well, the replica, the follower replica might need to consume the elements, but to consume the element, to persist the element, and to write it to the topic, it needs a bit of time. And by the way, this is a network call. So obviously this is going to take a bit of time. So it gives this guy a free hand. What this leader partition over here says that, okay, you are expected to have a lag, but you need to catch up with me in some millisecond. You can define any millisecond over there. Let's say we're saying over here, you need to catch up with this within 10 seconds, let's say. Let's say right now somebody push these 4 elements, U, P, and M to this test 1 topic. Now within 10 seconds, this test 1 need to make the request and need to persist the data and need to write it over here to its own partition. And if that happens, then it can maintain the broker with the follower replica in the in-sync replica list or in the ISR list. So if this goes down, then we can be very sure that this topic is almost caught off with this guy. And we can safely use it as a new leader because it's the most up-to-date replica that we have. Let's say like that, if the broker 1 is trying to catch up with the test 1 and it is basically trying to copy all the data from the test 1 within a lag of 10 seconds, then we can also consider the broker 1 in the ISR list as well. Okay, so this is how the broker 2, where the leader partition of test 1 exists, maintains the ISR list.
Another very important thing that you have to understand whenever you are working with brokers, producers, and consumers. Imagine you have 3 brokers. Now you have 3 partitions for test 1, and you can see that. And this is the leader partition, and these are the follower partition. And all these partitions are exist inside brokers, and these brokers may be in different data center. For example, this broker is in UK, this broker is in India, this broker is in US, for an example. Right now, imagine if you have a Kafka producer that need to produce the data. Then in which broker it will connect to? Well, that depends where the leader exists, as I told. For a test 1 partition, which is the leader partition that exists inside the broker 2. So the Kafka producer always going to connect to the broker 2, which has the leader partition for test 1. Just like that, if you have a Kafka console consumer, that always going to consume data from the leader partition only. But here is the catch. In the latest Kafka version, maybe from Kafka 3.2 or 3.3, or maybe 3.4, I exactly don't remember, but I will put that in the edit. From the newer version of the Kafka, let's say if this is the Kafka console consumer, and if this client application exists in US, for an example, then from US, if you are making a network call to India data center, there might be more lag over here. So in order to reduce the lag, from the newer version of Kafka, let's say if this consumer exists inside the US data center, or maybe this call is coming from US, it might have a call to the follower replica if that replica exists in a nearby location. For example, this consumer exists in US, this follower replica also exists in US. So maybe the Kafka console consumer can directly consume data from this follower replica if it is catching off well. So now you can understand how much important it is to maintain this follower replica, what we call the in-sync replica. So we always need to make sure the leader partition data should be copied to the follower partition, and at least there should be 1 or 2 follower partition which should be in our in-sync replica list. Always this data are getting copied to over here or getting copied to over here. So in a production application, you can also set it off. Like in every moment, you need to have 1 or 2 or 3 in-sync replicas set up. Let's say in a given point of time, there is no in-sync replica available, then you may stop the producer to produce the data to the leader. Because imagine if this broker is down, if this broker is down, and if you produce the data to the leader partition, and if we don't have any in-sync replica available, what if this broker also goes down? What if this Kafka console producer produce some data to here and write it to the topic, and then if this broker goes down, then we don't have any copy of this replica available inside this broker or this broker because they are also down. In this case, there might be a data loss. So it is very, very important to have a in-sync replica available like test 1 broker 3 and test 1 which is inside the broker 1. And we need to always make sure they're catching up well with this leader partition.
All right, so we have seen how important the in-sync replicas are. Whatever the leader partition that we have, where the traffic goes, where we write the data, we must have some copy, what we call the follower replica or the in-sync replicas. We at least need to have 2 or 3 in-sync replicas in a production environment. If you are not going to have them, then that will cause the data loss whenever your leader partition fails. Now let me prove the importance of this by giving an example to you, and let me tell you how to set off the in-sync replicas. Right now, let's just try to create a topic. Let me give the topic name as new test. All right. and the partitions I have defined as 1 and the replication factor as 3. That means we have 1 partition but 3 replica. So we are running this command over a 3-node Kafka cluster. So that means 3 replicas will be created and will be splitted over 3 different servers, and one of the replica inside a broker will be the leader partition. So for this new test topic, there should be at least 3 replica will be available. Out of those 3, 2 will be followers, 1 will be leader. The 2 followers replica, what we call the in-sync replica. But that might be a chance the in-sync replicas may go down or something might happen. So to avoid that kind of possibility, I'm setting off a minimum in-sync replica required for this topic. I'm going to show you exactly how this is going to matter. So let's say here, I'm going to set up some config for this topic, and I'm going to say minimum in-sync replicas required is 2. Let's just do enter. And it's created a topic called new test. Now let's just try to describe the topic. All right. So I'm going to run this command to describe the topic. Now you can see I have a topic called new test. There is a partition called partition 0. Now for the partition 0, there are 3 replicas available. Out of these 3 replicas available, the one which broker 3 contains, that is going to be the leader partition. So 3 replicas, but the leader is the one which is available inside the broker 3. But there are 3 ISR again. So one is the leader itself, and the other 2 replicas are available in the broker 1 and in the broker 2. And those are the ISR which is catching off with the leader partition. Now all looks familiar, but why did I set up this configuration for this topic, and why I said min in-sync replica need to be available as 2? Right now, everything is good because there are 3 healthy replicas available over here. Let me show you how this works. Let me take this thing to down, and right over here, let me connect to the topic that I have just created. So here I have a Kafka console producer, and I want to connect to the topic called new test. Now I'm connecting to the broker localhost 9092. Maybe here my leader is 3, the third broker, maybe which is running in localhost 9096 port number, but that's fine. My Kafka console producer can connect to either one of the broker, maybe broker 1 or broker 2 or broker 3, whatever it is. But whenever it is going to produce the data, internally, this producer is going to produce the data to the broker, which is the broker 3. Because here is only our partition 0 exists, which is the leader partition. All right, let's just try to produce the data over here. Let's just do an enter. And let's just try to push the data. Hi, hello, bye, goodbye, and last example. Okay, so everything is getting pushed. Let's just try to consume the data. So let's just write a Kafka console consumer, and let's just try to consume the thing from this topic. Let's say new test. So whenever you're trying to consume, I'm consuming by connecting to the localhost 9092. So even if you are consuming from this broker, so if you're going to do from a beginning, if you're going to try consuming everything from the beginning, you'll still be able to consume the data. Okay, but while you are consuming, you are actually consuming from the leader broker. Okay, so the leader broker exists inside the broker 3, but you can see I'm connecting to the broker 1 and trying to fetch the data, but still I'm able to fetch it, but I'm not actually fetching the data from the broker 1 replica. Rather, I'm fetching the data from the broker 3 only, because that's the leader partition from where the producer and consumer basically trying to communicate. So here, if you want to exactly want to communicate with that broker, what you can do just do Control C over here, create another producer, and let's just connect to the broker 9096. Okay, and let's just try to produce the data right now. Again, one more time, 1, 2, 3, 4, and all that. And let's just try to consume the data from the 9096 broker, which is the broker 3, which is exactly the leader broker. Okay, and now this is going to consume all the data from the beginning. Okay, so 1, 2, 3, 4, and all this data that we have pushed before, everything has been fetched again because we are fetching from the beginning. So I think you are understanding everything well over here. Now I have a question. Let's say if you are giving some more data, let's say 5, 6, 7, then all this data are going to the broker 3, which is actually the leader broker, where is exactly our partition 0 available. Now, whatever data that we are pushing to partition 0, which is available inside this leader broker, which is broker 3, these replicas are trying to be in sync. Let's say right now, I'm going to terminate the first and the second broker, which are also containing the partition 0 and working as the replica and following off with this particular leader, which is leader 3. Now I'm going to terminate the broker 1 and broker 2, which is holding this partition 0 as the follow replica. Right now I'll go to the broker 1, do a control C. Okay, now this is got terminated. Okay, now I'll go to the broker 2 and do control C. So now this is also terminated. So now you're going to see what is the problem that we have when we try to push the data. Now this is my producer, right? Now you can already see the producer is already trying to connect to the node 1 and node 2, and it is failing because the producer, as I said, is internally knows the different nodes available inside the Kafka cluster, and it is failing. Maybe it is trying to connect to them internally and it is saying node may not be available. Now let's just try to send some data using this producer. Let's just say hello world, and whenever we are trying to push it, looks like we're getting some errors. Let's just expand this and then let's just see what is the error that we're getting whenever we're pushing the data. You can see the error messages are rejected since there are fewer in-sync replicas than the required. So whenever I'm trying to push this message, these messages are not getting delivered to the topic. Now, as I said, whenever we send this message needs to deliver to the broker, which is having the leader partition. But as the topic that we have created expected at least 2 in-sync replicas to be available, and as 2 of our brokers are down right now, so the producer is not allowed to push the message to the broker where the leader partition exists. Even if we have one broker up and running, okay, this is the broker 3, which is up and running, and that's the leader broker. 3 is the leader broker, which is up and running. Still, we are having an issue to push the data to this particular broker because the in-sync replicas are right now not available. These 2 replicas or these 2 brokers are down right now. And also you can see in the consumer, we're not able to consume the data that we are trying to push. Let's just say we are pushing hello, hi, and I'm pushing some data. It is not actually going and ended off with an error message. And the message is not enough replica exception. Messages are rejected since there are fewer in-sync replicas than required. So to make it work, so here if you'll go again and start your server 1 and the server 2, and both of these nodes will be up and running. Once they're up and running and all 3 caught off well, we have 3 replicas available right now. So right now, if you can see, the broker will be normal in a while. So once everything caught up over here, now if you're going to try sending the data, let's just see whether this is going to reach to the consumer or not. Let's just say hi here. Okay. Bye. Hello. Dude. And everything is working. And everything we are able to push it over here. So this is how we can set up minimum in-sync replicas for a given topic, so that in any point of time, whenever you're pushing the data to one particular broker, you can make sure there are enough copies of that particular partition is available in other brokers. And that you can specify by using the minimum in-sync replica configuration. This is where I'm doing topic level setup for minimum in-sync replicas. We can also do the same thing in the broker level. You can just take this and can put it in your broker configuration file. Now we can put this into practice and can do some hands-on. All right, it's time to set up a multi-node Kafka cluster using the KRaft mode, and that too using the latest Kafka version available right now, which is 4.x. Okay, so we're gonna be creating a Kafka cluster using the latest Kafka version. So right now, if you're gonna see my versions that I have over here is Kafka 4.0, where the Zookeeper is completely removed. So whenever you'll be practicing it, you can practice it in this way. So right now you understand all the concept. It's all about replicating the same thing without using any Zookeeper in the latest version of Kafka. So let's just proceed. First of all, if I'll go to the recent folder and if I'll go to my temp folder, let me check if I have any Kafka log folder exist. In this case, I don't have any. So first of all, in order to start the Kafka server, I have to generate a random UUID and I have to format it. So to do that, I need to use the Kafka storage command. And I have to use the random UUID over here. And this is going to get me a random UUID. Then using this random UUID, I can format my log folder where I'll be storing my data. So I can just hit format. Okay. And I'm gonna do -t. I'm gonna give this ID over here. And then I'm going to give the configuration file over here. So let's just go to my configuration file. And I should be using the latest Kafka here. So let's just use the Kafka 4.0 version that I have downloaded. If I'll go to my config, this should be the properties file that I will be using. So I'll go to the terminal and I'm going to hit enter. Now this command should help me to format my Kafka log folder, and it should help me to generate a Kafka log folder. But I don't have any log folder generated, as I have told you in the newer KRaft version. With this command, you also need to specify one of this, like standalone, if you want to create a single node Kafka, initial controllers, if you want to create a multi-node Kafka, and no initial controllers, and this is for a different region. We will understand that later. Right now, if I'm going to use the standalone, obviously, this command will work, and obviously a log folder will be created for me. As you can see, the formatting is completed, and I think this log folder has been created under my temp folder. So right over here, you can see I have the log folder created where my topics and other things will be created. But I do not want this thing. So I'll be deleting this right now. I do not want to create a standalone server over here or a standalone node over here. I want to work with a multi-node Kafka where I can have multiple brokers communicating with each other. So in that case, I should be using this initial controller over here, and I need to specify all the initial controllers which will be taking part, or all the initial brokers which will be taking parts with my distributed Kafka architecture that I'll be creating where multi-node Kafka will be existing. So to do that, if I'm going to just to hit enter, nothing will work and it will not work. So there is a different way. I need to do the same thing, but just in a different way. So let me clear out everything and go back to our Kafka binary folder and start doing a setup so that we can create a multi-node Kafka cluster here using the latest Kafka version, using no Zookeeper, and using everything in KRaft mode. So I will go to the Kafka binary right now. So inside my Kafka 4.0, I'll go to my config folder, and right over here, I have the server.properties file somewhere. Okay. I'll copy the server.properties and I will create another folder right over here because I don't want to mess it up with here with this my original file. So I'll create a new folder and I'll name it as delete. Okay. And inside this delete folder, I'm going to do paste it. Okay. So there you go. That's my new server.properties file. All right. So I'm going to rename it first of all, and I'm going to say server1.properties, and I'll just change few things over here. Because right now I will be creating a multi-node Kafka. So I'll be needing 3 different server.properties file to create each of my broker. Okay. So for my first server, my first broker ID will be 1. So it's already set as 1. So right now, the next thing I will be doing here is the listeners. And as you can see, there are 2 port has been defined over here. One is 1992. You know that this is a default Kafka port. And there is another port is defined here called 1993. And that is a controller port. So how these 2 ports are different? Well, first of all, let me just change this 1992 to localhost 1992. And let's just change the controller port to localhost 1993. And let's just save it. Now let me explain what are these 2 ports and why we need 2 different ports over here. Well, whenever you start your Kafka server, by default, the server will be exposed as port in 1992. So if you want to connect to the Kafka broker, you'll be using this port. So if you want to create a producer or create a consumer, you want to do something with the Bootstrap server, you specify 1992. So this is an external port which has been exposed by the server. And if you want to connect to Kafka, you'll be using this. Okay. As a client, if you want to connect, you're going to be using this port. Now this one is my controller port. What is this controller port and why do we need this extra port over here? Well, for every Kafka broker, we also expose a controller port because a broker can be a controller. And this controller port can help different brokers to have internal communication. So if you want to have controller to controller communication, then the internal communication between the controller that happens with this port. Let's say some internal metadata will be exchanged between controllers, then they will be using this internal port. They will not be using the 1992 port, which is an external port. All good. But whenever we'll be creating our broker will keep the data in my KRaft combined logs. And let me just make it 01. The server 1 will store the data inside this folder. And that's pretty much it. And advertised listeners are already set to localhost 1992 and 1993. I don't need to change anything over here. And everything is good over here. And the node ID is 1, so all good. Only one thing, list of controller endpoints used to connect to the controller cluster. Well, so we'll be obviously creating a controller cluster, and all the servers who will be participate over here in our cluster will be defining their controllers over here. You can see by default, we have a single node Kafka controller we will create, or whenever we'll start our Kafka server, for a single node Kafka, the controller is exposed in 1993. As I said, if you're going to see the listener, the controller is by default exposed in 1993. So only the 1993 controller is available. But by the time we'll have more brokers available, we'll be writing their controller ports over here. But as of now, we don't have much brokers available. So I will just comment it. Whenever I'll be needing it, I'll just uncomment this line. Okay. So there you go. All good. So this is my first broker configuration. Now let me go to my folder. Okay. And I'm inside the delete folder. This is my first properties file that I have changed a bit. Now I'm going to paste it for 2 times and I'm going to rename it. So this is going to be my server2.properties. And another properties file I'll create for my third broker I'll be creating out of this configuration. And let's just change the configuration inside the server 3 and in the server 2. So let me open the server 2 as well. Let's go over here. Well, there you go. Server2.properties. Okay, let's just change this one. Now for the server 2, the node ID will be 2. Okay.
And the listener port I'll be changed again. This broker, whenever I'll create out of this configuration file, I want this broker to expose its port in 1994. Okay, so for external communication for producer, consumer, they will be connecting through this port number, and my controller port number will be 1995. Okay, so why I haven't given 1993 over here? Because if you remember in my server.properties, already I have taken the 1992 and 1993 port number for both my external and the internal communication. And for the server 2, I'm just changing the 1994, this port number, and the internal controller port number will be 1995. And let me also change advertised listeners, and also let me just make it exactly same as this one. This is 1994 and this is 1995. Okay, the controller port number. And what else? The log file for the server 2, the KRaft combined log 2 I want to create. And there we go. I'm all done. So the log I have changed, the port I have changed, all right, and also the broker ID I have changed. Okay, all good. Now let's just go to server 3.properties. Okay, so node ID will be 3, and then the listeners, I think 1992, 3, 4, 5 is gone. Now this will be 6. And the controllers for the internal communication will be exposing the 1997 port number. So it should be 1996 and this should be 1997. Okay, so there we go. And it should be logs 3, KRaft combined logs 3. So all our 3 server 1, 2, 3 properties file are ready. We can run the Kafka server right now using all this properties file that we have. So all these 3 controllers which will be created out of this 3 server.properties file will be communicating in a cluster, okay, for their internal communication. And to define those things, I think we need to use initial controllers. I'm inside the Kafka documentation, and this is the command. Now we need to run the Kafka storage command, and we need to give our configuration file. But along with that, we need to define all our initial controllers, like whatever controllers that we have created. We have to give the controller name here, and the controller and the port number over here as well. So like that, we have to define all our initial controllers here so that we can create a Kafka cluster out of all the controllers which are available. Okay, so in order to do that, first of all, we need to have the Kafka storage command, and we need to find a cluster ID. Okay, we need to format the cluster ID. But here a lot of things will go on. Okay, so how to find the cluster ID? You can see here in the Kafka documentation, they're using the same Kafka storage command, random UUID, to create a cluster ID. Okay, and like that, for each of the controller that we have, let's say we have 3 different controller, then we have to create 3 different UUID. And all this UUID we can directly generate using the Kafka storage command, random UUID, the way we are generating a UUID to attach it with all of our individual broker. Okay, so I'll tell you how all these things works. Let's not go mad if you are looking into this particular command for the first time. Obviously this will be confusing, so let's just try to simplify this. So I will go back to my terminal over here. So what I'm going to do, first of all, before we basically use this initial controllers, let's just find all the data that we'll be needing to put it inside the initial controller. Like a lot of data they are generating, right? So we're going to be also doing the same thing. So let's just come back to here. First of all, I'm going to do this. Let's say I'm going to do Kafka storage, okay, .sh, and let's say a random dash UUID. Okay, if I'm going to do enter, then I'm going to get a UUID over here. Okay, that's fine.
But what I'm going to do right now, just to make it simple, I'm going to wrap it off with a brace, okay, open parenthesis and close parenthesis, and then I'm going to take this value dynamically, whatever this value it is going to give, I'm going to assign it to a variable, and I'm going to say that variable is, let's say, cluster ID. Cluster underscore ID is equal to this. All right. Now, if I'm going to do enter, so whatever UUID has been generated, that has been assigned to this guy, right? Now, let me print it. I'm going to say echo, and I'm going to print, let's say, cluster ID is, then whatever the ID that I got over here, this is a dynamic value. So I'm going to say cluster ID. Okay, let's just do enter and look at this. Cluster ID is this value, right? Now, let me just generate few more, IDs over here. So as you can see, whenever we are giving the initial controllers, whenever we're using this, here we are giving three things. First of all, the broker ID. Now for that broker, whatever controller that we're using and the port number. So let's say for the 0th broker, this is the controller and the port number. And then it is giving a UUID. So it is generating a UUID over here using the storage command. And whatever UUID we're getting, we're attaching it with each of our controller, something like this. For first broker, this is the UUID. For the second broker, this is the UUID. For the third broker controller, this is the UUID we're attaching. So we need to find three different UUID. So let me copy paste. I have actually copied all these things from my notepad. So basically I have typed the entire thing. So see what I'm doing. I'm doing the same thing. I'm using the Kafka storage SS command using the random UUID, assigning it to a cluster ID because I'll be creating a cluster. So I'll be needing a cluster ID, and then I'm echoing the cluster ID. I want to print it on my terminal like that. I'm doing Kafka storage random UUID and I'm generating a UUID and assigning it to this UUID variable. And doing it for 3 times because I have 3 different server, and for each server I'll be needing a separate UUID. So I'm creating 3 different UUID over here and I'm echoing each UUID over here. Okay, and I have copied it from my notepad right now. So I made sure the double quote that I'm giving over here, mostly this is the problem the people face whenever coding it. The double quote format is different. So if you're gonna directly copy it from notepad, it will be a stylish kind of quote over here. So for terminal, it will be a straight quote like this. So make sure the quotes are straight, otherwise you will get an exception and things will not work. Okay, let's just do enter. All right, so I got my cluster ID and I got my UUID over here. For each of my broker, I'll be using all this UUID. Okay, perfect. All right, so right now, let's just go ahead and let's just try to format our cluster. So you can see we're using the Kafka storage command and we're using the same format and we're giving the cluster ID. Cluster ID should be one of the random ID that we would have generated over here. Okay, and then to this cluster that we'll be creating out of what server. So first of all, we will be giving one of the configuration properties to our cluster. Then we'll be defining the initial controllers. We'll be coming into this, but first of all, let's just try to use the Kafka storage command here. So I will go back first of all, and I'm going to use the Kafka storage command. So I'm going to write Kafka storage sh, then I'm going to do format. Okay, then I'm going to format the cluster ID. So I'm going to write cluster ID, something like this. And the cluster ID, I'm going to take this. So here I'm printing all the IDs and I'm going to put it right over here. Okay, there you go. That's my cluster ID. The next thing is the configuration, as I have said. So cluster ID is done. Then I'm going to come to the initial controllers. Let's just work on the config. So here I'm going to use, let's say, config And let's just give one of the properties file. So first of all, let's just try to create and format the folder where my server 1 or the Kafka broker 1 will run. So I'm going to take one of the server 1 properties. Let's just say it is going to create the folder where the log file will be stored behind the scene, because the Kafka CRaft doesn't use Zookeeper. So I'm going to use this. Now if I'm going to do enter, by the way, okay, it will not work. So it is saying you are creating a cluster over here. So whenever you're creating this broker, okay, using this configuration file, then also tell what are the other servers which must contain the set of bootstrap controllers. Okay, so I need to define the other controllers which will be also be part of this cluster. So let's just rerun this. Okay, so I'm going to just rerun this command. I'm going to come into this exception. Don't worry about it. I'm going to read it again. We'll tell you exactly what you need to do. But in short, what we need to do, we need to specify a set of controllers over here. And to specify a set of controllers, you have to use this command. Okay, initial controllers. Let me copy this, initial controllers, and you need to put it over here. Something like this. And you have to define all your initial controllers right over here. So my initial controllers are, I'm going to define it over here. So the first one, the first controller, the way I need to specify here is, if you can see this. So here, maybe for the server 2, my controller is localhost 1995. Okay, for the server 1, the node ID is 1 and the controller is there at localhost 1993. So I need to specify all those things. The format I need to specify, I need to first give initial controllers, then 1, which is my node. Then for the first node, the controller is sitting at localhost 1993. Okay, for this controller, I'm going to give a UUID. Maybe for the broker 1, this is the UUID. Let me copy this and put it over here. Okay. Now I have to define the second controller over here, because in my cluster, this controller is also going to be part of it. So the second controller is localhost. And if I remember well, it is on 1995. One of the UUID I'm going to give it. So I'm going to copy this and I'm going to put it over here. Okay. And then I have to define the third controller. So I'm going to give another comma, 3 at the rate localhost colon 1997, and I have to define this guy as well. Okay, and there you go. My first broker should able to format. Where is my log folder, by the way? So I'm gonna see the temp folder. Here I should have the log folder available for my first broker when I'm gonna hit the command. Let's just see whether that is working. So if I'm gonna do enter right now, well, I got still a problem. And what is this problem? So it is just saying we got a config exception. If you're using processes role, either controller quorum bootstrap server must contain a set of bootstrap controllers, or this property controller quorum voters must contain a parsable set of controllers. So what it is saying that whenever I'm gonna hitting this command, is fine that I'm gonna say these are my initial controllers which will be available inside my cluster. But along with it, I also need to tell in my configuration file that what are the set of controllers which will be taking part of the cluster. So that I need to define over there using either of this property. Using this property, if you remember, there was one property, but I have commented it. So I need to either use this property or I can use this controller quorum voters property. So controller quorum voters, I will copy this. Okay. The name is fascinating, right? Controller quorum. Quorum means a smaller member voter, you understand. That means we'll be defining all our controllers, will be participating and voting who will be their leader, who will be the followers and all that. Okay. So right now, controller quorum bootstrap server, I have commented it out. So if you want to uncomment it, you can specify all your controllers available, but let's just go with this property right now. And here I'm going to specify all my controllers. Let's say the first controller for the first broker is localhost 1993, Control C, Control V. And then the second one will be the broker ID 2, and it is available in 1995. The third one is available in third node, and it is available in 1997. Okay, these are all my controllers which will talk to each other internally to make sure that communication is going on, and they will be able to vote whenever the leader they need to choose and all that. Okay, we'll be coming into that, as I said. So there you go. I'm going to copy this. I'm going to put it in each of my properties file. So right over here also I'm going to put, right over here also I'm going to put. Okay, now let's just come back to my terminal. And now let me just do enter one more time. And let's just see if things are working. And obviously, now formatting temp KRaft combine logs 01 with metadata version 4.0. With this version of Kafka, we have formatted our log file. And I think right now, if I'm going to go to our folder, I have this KRaft combine logs 01 where my Kafka broker 01 will be keeping its data. So let me right now create and format a couple more log folder where my server will be keep on saving their data. So I'm going to do clear over here. I'm going to get back this particular thing and I'm going to format the same thing for server2.properties file. And I'm going to use the same cluster ID. Everything will be same. Only the server2 I'm going to use. Do enter. Okay. And this is done. And now I'm going to do the same thing for server3.properties file. Server3.properties, enter. And there you go. So if I'm going to check my my temp folder right now. So there you go. I have 3 different log files. Right now, let's just start our server. So here my Kafka broker will run. The 3 different brokers I have. So first of all, I'm going to do Kafka server stat. Okay. And I'm going to give the first properties file. And here I have server1.properties. I'm going to copy this and I'm going to put it over here. All right, Kafka server stat. And this is my server1.properties. I'm going to copy this and I'm going to paste it over here. This is going to be my server2.properties. I'm going to start my server with. And here I'm going to paste it again. And this is going to be with my server3.properties, right? So I'm going to do server3.properties. Okay. Okay. So right now, let's just try to bootstrap our server, Kafka server start.sh. And I'll be starting with the server1.properties. Let's just do enter. Now my Kafka server started, but it is looking for the other nodes so that it can communicate with them. So let me quickly start the server2 as well so that it can register with itself. And let me also start the server 3 as well. Okay, so all my 3 server can start right now. The Kafka server has been started. Here the node ID 2 Kafka server has been started. And here node may not be available, but anyhow, after a while, again, the connection will be established with all these 3 nodes, right? So make sure that all of your 3 nodes are up and running. And right now, let's just go ahead to my terminal. And let's just try to create a topic over here. Let me just do clear. Now let me create a Kafka topic and I'm going to connect to, let's say, localhost 1992. And let's say the topic that I want to create, the name will be, let's say, test. And I'm going to do enter. Oh, sorry, there is a typo. Let's just do enter. Now the topic has been created. Oh, sorry. I have to create the topic with some partitions, right? So let me just say partitions. And let's just say 3 partitions. Let me create another topic called test 2. Let's just do enter. Partitions. Let's just do enter. All right, the topic 2 has been created, and let's just try to describe the topic. Let's just do enter. And you can see right now, we have 3 different leader. They have been splitted across, and the replicas are right now only 1. We haven't created more replicas over here. Right now, let's just go to our log folder. Let's just go to the log 01, and you can see the test2, the second partition is over here. 02, this partition is over here. And let's say 03, this partition is over here. Okay, so now the cluster is in action, and we have a multi-node Kafka server, and all these 3 servers are up and running and transmitting the data and having communication with each other.